Full-scale structural and non-structural construction procedure of a multi-story test building at the Englekirk Structural Engineering Shake Center. Module 6, Non-Structural, Facades. Objective 1. To provide an overview of the various types of architectural facades used in buildings. Objective 2. To present the materials, detailing, and installation methods used when installing metal stud-type facades. Objective 3. To present the materials, detailing, and installation methods used when installing precast concrete-type facades. A facade is the exterior side of a building. Its purpose is to enclose and protect a building and its occupants from the outside environment. Additionally, facades are used for aesthetic purposes in order to provide architectural appeal and finish to the building. Coming from the French translation of frontage of face, a number of different types of facades are used, such as precast concrete walls, cold-formed steel finished with stucco, glass, mixed material such as steel framing and glass, and curtain walls. The choice of which facade to implement on a building depends on a number of factors. For example, concrete is heavy, yet environmentally more rugged than glass, and hence would be used in a high wind region rather than using a glass facade that goes the full height of the building. Precast concrete walls are made off-site and brought on-site for installation. Some walls consist of steel-reinforced concrete ribs that run vertically and horizontally in the panels, while others are solid. One of the most important advantages of precast concrete walls is that they maintain high-quality assurance and resilience. This is due to the fact that walls undergo quality control during the construction process at the production plant in comparison to concrete walls that are mixed and poured on-site. Using precast walls can result in faster erection times on-site. The walls are reinforced with steel rods, providing stronger resistance to wind and earthquake loads. However, precast concrete walls are very heavy members and need to be transported on-site for erection. During erection, there is typically a very small margin for error in lining up the walls, and the connections may be difficult to construct. In addition, skilled workers are required to install the panels on-site using cranes to lift the panels. Cold-formed steel walls are made by rolling or pressing thin gauges of steel sheet at room temperature in comparison to hot-rolled steel shapes which are formed at elevated temperatures. Some advantages of cold-formed steel walls includes being cheaper than many other materials to build houses such as wood. In addition, building light-gauge steel framed houses take less time to construct than wood. Also, in comparison to wood, steel walls have greater strength than wood, and hence this usually translates into a need for fewer members when constructing. However, a couple of disadvantages include being difficult to connect and the problem of being low fire resistant. Curtain walls serve as an outer covering of a building where the outer walls are non-structural and hence their only purpose is to keep the weather out and the occupants in. Since curtain walls do not carry any of the loads from the building other than their own weight, they can be made out of very light materials such as glass. However, curtain walls still need to be able to redirect forces that occur on the building, such as horizontal wind loads, to the building's structural components such as the columns and floors. A 5-story building fully equipped with structural and non-structural components was tested on the NEES shake table. The architectural envelope of the building consisted of 2 different types of facade systems in order to test how the different types of systems performed under seismic forces. The first 3 floors were fitted with balloon framing, while the 2 top floors consisted of precast walls. An introduction to these 2 facade systems and their installation procedure will be described in this video. Facades must be able to deform with the building. Facades that are connected from floor to floor must be designed to allow for relative movement between the 2 floors. These deflections might be induced by temperature, structural materials contracting or expanding during weather changes, or more extreme earthquake and wind events. Since facades, for example curtain walls, cannot typically carry large loads because their main purpose is to keep air and water from penetrating the building envelope, the loads that are applied on facades are usually designed to transfer directly to the building skeleton, such as the columns or floors. Therefore, the 2 main loads that facades carry are self-weight, which is the weight of the facade itself, and lateral loads, such as seismic forces or wind loads, which are transferred immediately to the building skeleton. In the 5-story building case study described in this video, the 2 facade systems, balloon framing and precast concrete walls, differed considerably in the time required for installation. Balloon framing is a composite system consisting of lightweight metal framing, gypsum board, and a synthetic stucco finish. Gypsum board, also known as drywall, is a panel made of gypsum plaster pressed between two thick sheets of paper and is usually used to make interior walls and ceilings. Synthetic stucco is a barrier-type cladding system that relies entirely on the exterior surface to keep moisture out. In general, balloon framing is installed from the ground floor to the finished floor. However, an alternative installation method termed platform framing can be used to install facades from floor to floor. The installation of the balloon framing took several months to complete and required the use of temporary scaffolding. Scaffolding is a temporary structure that is used to support people and materials used in construction of a building. In contrast, the precast concrete walls only required a few days to install since they were constructed off-site and were ready for lifting and fitting once they arrived. The first 3 levels of the 5-story building were fitted with balloon framing overlaid with a synthetic stucco. The metal framing consisted of gauge 60 steel studs spanning vertically from the foundation of the building up until the 4th level floor slab. Horizontal tracks at the top and bottom of the studs connected the studs to each other. Light gauge steel clips that were screwed into the steel studs were used to attach the metal framing to the structural components of the building, such as slabs, beams, and columns. The bottom track of the framing was attached to the foundation with shot pins. A shot pin is a fastening device that is installed using a powered charge to embed it into the concrete or steel. The gypsum board, which measured approximately 15 millimeters in thickness, was then installed and screwed to the metal studs on the inside and outside of the framing. Finally, the synthetic stucco, called the Exterior Insulation and Finish System, EIFS, was applied. This system consisted of a waterproof coat made of a 40 millimeter polystyrene layer. The precast walls were delivered and installed on the 4th and 5th floors of the building. Precast concrete is essentially the process of casting concrete in a reusable mold in a controlled environment and then transporting the prefabricated components to the construction site to be lifted into place. In this case, the walls were made out of precast concrete off-site with desired dimensions and then brought on-site to be fitted to the structure. The wall panels in this case study were punch-out window walls, meaning the wall panels spanned from floor to floor with openings provided only for windows. 2 precast concrete panels were fitted on each side of the building on 2 floors, resulting in a total of 16 panels. The panels were 125 millimeters thick and reinforced with a number 4 reinforcing bar, which is a ½ inch in diameter, placed at 300 millimeters on center, which means 300 millimeters between each bar. The panels were then finished with the application of caulking, which is used to seal the joints and seams in a structure in order to waterproof the structure. When the precast panels arrived on site, workers removed the safety metal plates off the panels before lifting them in place. The panels were designed with 3 or 4 hinges so that when they were lifted to the appropriate level, workers could connect the hinges to the embedded plates inside the building. The weight of each panel was supported by bearing connections at the bottom. A bearing connection is one of the most common types of bolted connections. It is used in most simple shear connections and in situations where the loosening or fatigue of bolts due to vibration or load fluctuations is not a primary design consideration. During the installation of the precast concrete panels in the 5-story building, one problem that repeatedly occurred was the ropes used by the crane to carry the panels repeatedly got tangled. This video, which is the 6th in a series utilizing data collected from a full-scale building test program conducted at the University of California, San Diego, was intended to provide an overview of the various types of architectural facades used in buildings and to present the materials, detailing, and installation methods used when installing both metal stud type facades and precast concrete type facades.